Hola. Well, that's the way we say hello in Spain. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics, where today we'll be discussing about heights and distances. Here, we will be looking up what actually is the significance of finding out heights and distances. How is it found out by using a right angle triangle? Which are the different trigonometric ratios that we require to find values of, and what exactly are their values? Further, we'll also be looking up what is the angle of elevation, what is the angle of depression, and how to put them in a right angle triangle so that certain heights and distances can be found out. I'm going to make this really simple, so make sure that you're here till the end of the lecture and absorb everything. Moreover, I'm sure you people must be perplexed as seeing to this environment where we're having this. That is because I want to keep the environment really colorful and light so that studies happen in a very easy way. So here at this moment, we are at this lovely location where I want you people to meditate that we are actually having our class. So this is Montfranc, Mount Perdido National Park, Spain. It is among the top 3 tallest of the mountain cliffs among the Pyrenees ranges, which is along the border of France and Spain on the valleys of the Tagus River. More about this and what all you can do here is what I'm going to discuss in times to come. We will also be having some jokes. We will have some things which are about the tradition of this place, something that we can learn from, and also some sweet dishes which I'm sure I'm going to serve you when you feel really hungry, getting a little tired after a lot of studies. So be ready for all of this and let's start this journey. Okay, children, so the first thing that I want to tell you people was about actually what is heights and distances. Now, for that matter, let us consider that we have, say, some point which is at the base level, and let's say now that we want to find out, say, another point, right, which is above it. For that matter, let us consider that this be the base, right? And let's say talk about Ashok who here is in the class, and let's say there is a very high building, say some 16-story building which is there, and he is trying to see the terrace of the building where probably he has seen something which has really interested him, right? I don't know what it is, but he is just seeing it, right? And when he is just seeing it, obviously he will be seeing it in this way, that is, his eyes will be joined to the object. So we can consider that this actually is the point where we have the eyes of Ashok, right? And this is the object of his liking. So we will mark it to be, say, some P, right? And let us say that this is the foot of the building. Okay, so whenever a person watches something which is above him or her, then we call in the angle of elevation. Now, what is the angle of elevation? It is the angle between a straight line drawn from the eyes to the object, which is known as the line of sight. That means the line along which you see is actually your line of sight, right? And if you find out its angle from a straight line which is drawn from the eyes and parallel to the base, then that becomes the angle of elevation, right? And we normally depict it by writing in the suffix of theta, E, which shows that this is the angle of elevation, right? So all of this I'll just quickly repeat. Now, when we talk about watching an object which is above our height, right, then we call in angle of elevation. Now, what is angle of elevation? Here we've considered there is a person, Ashok, who is watching something at the top of a building which is 16-storied building, might be say some 1000 feet building, right? And he is watching the top of the building. He is watching something of his interest, which can be a bird, which can be a person, probably it can be anything else. But when he is watching it, then obviously this straight line, which is the join of his eyes to the object that he is watching, is the line of sight. And if we find out the angle which this straight line has with another straight line which has been drawn from the eyes of the observer parallel to the horizontal, then we call this to be the angle of elevation, right? Now, this is only when a person observes something which is above his height. I'm sure there are many times when you try and see something which is above you, and that is when we call in the angle of elevation. Now, contrary to this, there can be another case where there can be a person who is watching something intently below their height. And when that is the case, then you will say that you will be calling in the angle of depression. So let us now consider this, that we have here again another right angle triangle which is to be made. And let's say in this case that we have, say, a person, right, who say, let's say we have Hema here in the class. So let's say Hema here is at the top of say a tower, right, which she's reached, right, and she's trying to actually find out where her father is, from where she can wave to her father, right? So now we'll be making another straight line which will show the base on which this tower is standing, and say this is that base. Now we will join Hema's eyes to the object that she wants to see, that is her father. So here what we'll do next is we will now be joining this to the object which he's trying to watch. So here we'll be joining Hema's eyes to the object that she is watching, and this is that straight line. So I'm sure you people must be knowing here what is the line of sight. Yeah, Hema, can you tell me? It is your case, okay? Yeah, very correct. If we talk about this straight line, which is the join of her eyes, right, to the object that she is watching, then that actually becomes the line of sight, right? Now, as we've talked about the angle of the line of sight with another straight line which is parallel to the horizontal, which is drawn from the eyes, remember. So here now we'll be drawing another straight line which will be drawn from the eyes of the observer, that is Hema, and this straight line is going to be parallel to the horizontal, something like this. And here now, children, if we talk about the angle which is between both of these straight lines, then that will be known as the angle of depression. And like I told you, so that we can understand this more, what is done is in the suffix there is a small d which is written, which actually shows that this is the angle of depression. In both the cases, the angles are represented by the Greek alphabet theta, but when we have in the suffix of theta e, then it shows that that's the angle of elevation. And when in the suffix of theta we have d, it shows that it is the angle of depression, right? So all of this I will just quickly discuss with you people, but before that I'll quickly like to write what this theta d is. That is, this is the angle of depression, and there is nothing to be depressed about this. That is, when actually you depress your side, that means you put your side down and you try and see something, then we call in the angle of depression. Obviously there can be thousands and millions of cases where you have angles of depression or angles of elevation getting formed in, say, your life cycle. But at the moment we are just interested when Hema is standing here at the top of the building, right, Hema? And she's trying to watch her father, and she wants to wave to her father. As such, the object that she is wanting to see is her father, and the person's eyes is here. Now, straight line joining the eyes of the observer to the object that the observer is watching is the line of sight. Now, the angle which this straight line makes with another straight line which has been drawn from the eyes of the observer parallel to the horizontal, right, will be said to be the angle of depression. Now remember here, in the earlier case, the angle was found out from the horizontal, right? That means the angle was found out between this line and the other line which was there in the triangle. However, when we talk about the angle of depression, you get to see that this angle is actually coming out of the triangle. But the concept remains to be the same. That is, when we talk about the angle between the line of sight and another straight line which has been drawn from the eyes of the observer parallel to the horizontal, then we get in the first case the angle of elevation, and in the second case we get the angle of depression, right? So here I'm sure all of you people must be perfectly clear about what angle of elevation is and what angle of depression is. Okay, Soham, so you're interested in wanting to know this once more. Okay, so let's say now we try and understand this, that if say we here have say Soham who is standing here, right? He say is at the street level and he is trying to watch something which is atop a tree. Might be there is a very colorful butterfly which he has got to see and he is watching it intensely. So the joint of his eyes to the object that he is watching is the line of sight, and the angle which the line of sight makes with another straight line drawn from the eyes of the observer Soham parallel to the horizontal is known as the angle of elevation, right? Now when we talk about the angle of depression, a person should be looking below his height. So here we consider the case of Hema, who was trying to see her father so that she could wave to her father. So a straight line drawn from the eyes of the observer Hema to the object that she is watching, that is her father, becomes the line of sight, and the angle that this straight line makes with another straight line which has been drawn from the eyes of the observer, that is Hema, parallel to the horizontal, right, is the angle of depression. So is everybody clear about all of this? Yes, Soham? Sure, good. I want everybody in the class to understand everything that I'm teaching you people. Now children, after this I have a chocolate for you people. Do you know what a chocolate is? Okay, some amusement. Okay, I'll tell you. Now as here in this lecture we are talking about Spain, so I'll tell you something really interesting about Spain. Do you know what the Spanish people are known as? No, they are not known as Spaniards. They are not known as Spanish, but there's something more which is attached to one who is a Spanish. Yeah, the Spanish person is normally considered to be one who is laid back a little. That means who is lethargic, a little lazy, and who puts the things for tomorrow. And that is how normally a person who is Spanish, right, is said to be one who keeps everything for tomorrow, right, and just tries to procrastinate everything, and thus he is said to be lazy and somebody who's not trying to do work, and one who takes life pretty easily, right, in a way that is normally not liked by a person who wants some action to be got done. This, children, is normally said by a word which is known as manana, right? So manana means tomorrow. So Spanish people are normally said to be manana people, that is tomorrow people, because they put everything for tomorrow. Okay, I'll do it tomorrow. Okay, I'll do it tomorrow. Okay, now this is something which is really funny, and I'm sure you people must not be knowing this about the Spaniards. Okay, now there'll be more, something about the football team, something about their lives, and much more. Now at this time I would like to now further progress with the details. I will be discussing a sum and then there'll be more fun, right? Okay, so let's get started, children. I have this very simple sum for you people which I like you people to quickly try, right? And after that I'll be discussing the sum in detail. So get started. Make sure, children, that you are seated at a place such that there is no disturbance and is all secluded, right? You do not have any TV, any mobile device, or some friend, brother, sister, etc. disturbing you. And make sure when you understand, you are to focus exactly where my pointer is, making sure that you're sitting on a table and chair and not lying on a table and just trying to relax, because this is not a movie. This is something which after learning you also have to perform, right? Okay, so now, children, considering that you people have given it a good try, but because most of you people are online, rather for those people who are online, I like you people to pause this for a longer duration of time and then give it a bigger try, right? So here, children, in the question we've been given, what is the angle of elevation of the sun if the length of the shadow of a boy is equal to his height? So there was probably a boy who was moving around and he found that there was some time of the day when the length of his shadow was actually equal to his height. So let us try and figure it out with the help of a diagram. So here, children, let's consider that here we have the boy, right? And after this, now we'll be making the ground level. So let us now say that we have the ground level to be, say, something like this, and there is a time of the day when he finds that the sun's rays coming through him, as he is opaque, but the ones which are not able to pass through him were actually those who made such a shadow, such that the length of his shadow was actually equal to the height that he had, right? And now here, children, this is approximately the figure, right? So let us now consider that we have this boy. Now let us name him to be somebody from the class. Okay, Arnav. Okay, let's say Arnav was there, who was trying to do this experiment. You did this experiment? Okay, so now you do this experiment. So children, here, as we consider the boy to be watching perpendicular to the road, normally that is how you watch, right? You know, Michael Jackson, that you fall like this, right? You normally watch a person walking such that the person is always walking perpendicular to the ground, right? So when the person is walking perpendicular to the ground, the angle between the person and the road can be considered to be 90. So we can say that this angle is 90, right? Further then, if we talk about the angle which this sun here makes with the positive direction, right? This is, say, the sun, right? And we've got to find out the angle which it makes with this direction, and let us name this angle to be, say, some theta d, right? And we want to find out, theta e, as this is the angle of elevation. So this actually will be the elevation of the sun when the person's shadow will be equal to the length of his height. Okay, so if, say, we talk about this to be the height of the person and we mark it to be, say, some h, then obviously the length of the shadow also is h, right? And now here, remember, children, as this is the known or the unknown angle, the side which is in front of it is the perpendicular, right? And the side which is opposite to 90 degree is the hypotenuse, right? And the third side obviously becomes the base. So here we have the base, right? Now, as you know, these three things are very important. That means which side is what, and all of that depends upon the angle where actually this angle, which is not 90, is located. If we would have had the angle to be here, then this side which is opposite to this angle would have been the perpendicular, like it was in this case. The side which is opposite to 90 will always be the hypotenuse, and then the third side would have become the base, right? So as such, knowing these sides is very important, as now we next talk about the 6 trigonometrical ratios. That is, we talk about sine theta, then we talk about cos theta, then we talk about tan theta, and normally these are the 3 which we try and find out values of with the help of the lens that we have, and then we further with it find out some heights and distances. Now, as you know that sine theta is equal to perpendicular upon hypotenuse, so this is what it is going to be. Then if we talk about cos theta, it is base upon hypotenuse, and if you talk about tan theta, that is perpendicular upon base. Now, do remember that if we talk about sine theta, it is actually the inverse of cosec theta. So if in some question you find to be cosec theta, then you're going to write it to be hypotenuse upon perpendicular. Now, the inverse of cos theta is sec theta. As such, if you talk about the value of sec theta, it will be hypotenuse upon base. And then if we talk about tan theta, that will be base upon, tan theta is perpendicular upon base, and its inverse is cot theta. And thus, if you talk about cot theta, then that becomes equal to base upon perpendicular, right? So these are the 6 trigonometric ratios which can be found out with the help of a right angle triangle. Okay, there is one doubt which Sonal has, and that is this, that how is it that we are trying to find out the height of the sun with this? Actually, if you talk about the height of the sun, we are trying to find out the angular height of the sun, right? Remember, there are two distances. One distance is the linear distance, and the other distance is the angular distance when there is a body which also performs circular motion, right? For an example, let us quickly consider that if we talk about, say, a circle, I'll quickly show you both of these distances. Now, if, say, we talk about, say, a circle, and let's say that there be a circular bridge on which, say, a person is traveling, and now if you talk about the distance that this person has traveled on the bridge, then if you talk about this to be point A, this to be point B, and this to be point C, and there is this person who is actually walking on this bridge, right? Then we can add up this arc length and this arc length to give us the total amount of distance that this person has walked. Now, as you see that this is actually the distance that we are talking about, or it is the length of path that we are talking about. Now, this can also be found out if we consider this to be, say, the center of the circle, and then if we join it with the initial point from where he started to the final point where he later reached, which, say, is this, then we can even find out the angular distance, right? This angular distance, remember children, is known as the angular displacement. Either you just call it the angle or it is the angular displacement. I have referred this to you people at this time, but in times to come in higher physics as well as in mathematics, you will be studying about this, right? So when we talk about the length of the arc, then that is actually the length of path that the person has traveled in moving from A to C. But if you want to find out the angular distance that the person has traveled, then that will be the angle that the person has traveled in by a radius which is drawn from the point A, then to a radius which has been drawn from the point C. So whatever is the angle in between, that will be said to be the angular displacement of the person, right? So here children, now we are talking about the distance, which is the angular distance, and thus with that then we are finding out the elevation of the height of the sun with the help of the angle with respect to the horizontal. And here children, we have taken it to be theta E. Now we will consider here these two sides which have been given to us, and with the help of that you will find out this angle theta. Now, as you know that the side which is in front of this angle theta is the perpendicular, and the side which is the third side is the base, after considering the side which is opposite to 90 degree to be the hypotenuse. Thus we have the perpendicular and the base, which should be able to form a trigonometrical ratio, and here children we call in tan theta. We will say that since tan theta is equal to perpendicular upon base, therefore now you will talk about this triangle, which we can name to be, say, some A, we'll not take B, so let's take something else. Let's say we take it to be XYZ, right? So let's say we have this to be X, this is Y, and this is Z, right? So in triangle XYZ, right, we can now say that we have tan of this angle theta E, which will become equal to perpendicular upon base, and here perpendicular is H children, that is the height of the boy who is moving around, and it will be divided by the height of his shadow, which is the base. Now children, here you get to see that we have thus tan of theta E to be equal to 1, as both of the h's are identical entities in multiplication and thus will get cancelled. And thus here you can say that tan of the theta E is equal to 1, and this happens only when you talk about tan of 45 degrees. And therefore you can say that theta E, which is the elevation of the sun, is actually 45 degrees, and this children will become the final answer. So I will just quickly discuss this once more. Here in the question you've been given that you've got to find out the elevation of the sun if the length of the shadow of a boy is equal to his height. So let us consider that there is a boy who is moving on a road on a sunny day, and that is when he finds that there is at some time his height equal to the length of his shadow, right? So he looks it up and he does that for a few times, right? And he finds that it's actually true. And then he puts out the question, what will be the elevation of the sun? And that is what we are doing now, right? Just joking. So here, children, let us say that we have, this is the boy, this as his shadow, right? And here, if you join this point along to the top of the boy, that is the head of the boy, and across, obviously this is the line along which the sun's rays are coming, or the sunlight is coming. And because the boy is opaque, as all of you people are, so obviously the light won't be able to move from within him, and thus the opaque body will cast a shadow, and that is this. Now here, children, as we can consider that the boy is going to move such that he is vertical or he is perpendicular to the road, which is horizontal, thus we can consider this angle to be 90, and this is a right angle triangle in which this angle will give you the elevation of the sun. Obviously this is no distance, but this is actually the angular distance, right? And this angular distance, or this angle, has been considered to be the angle of elevation of the sun, right? Now we've got to find this out. So what do we do is, as we know that this length is equal to this length, we mark it to be both h, and further the side which is in front of this known or unknown angle is the perpendicular. The side which is in front of 90 is the hypotenuse, and the third side is the base. So as we have the base and we have the perpendicular, so we are now going to include such a trigonometrical ratio which has both of these, and as such we will call in tan theta, which is perpendicular upon base. Remember, we talked about it earlier, right? Now children, we will talk about this right angle triangle where all of this is happening. We'll mark it to be, say, some x, y, z, right? And then we have tan of this angle, that is theta e, that is the angle of elevation, to be equal to perpendicular, which is h, divided by base, which is also h. As both of these are identical, they will slash each other, and thus you will just be left out with 1. And when is it that you get tan theta to be equal to 1? When theta is 45 degrees, right? And as such, here you will get to see that theta e will come to 45 degrees, or in other words, the angle of elevation of the sun when the height of the shadow of the boy is equal to his own height is actually when the elevation of the sun is 45 degrees. So this is how you will do the sum, and I'm sure if you do it this way, you will get full marks in your board examinations, or probably any exam that you appear for. Now children, this was a very simple sum. I have more sums for you people, for which I will now provide you people a link. When you get to the link, then you will have a greater practice of the topic, which is heights and distances, and have a deeper perspective about it. That is something which is very important, because questions that come actually want you to think much more, and that's why more practice is required. So make sure you click on the link and go and see that lecture, so that your concept about heights and distances is further broadened. And for the time being, that is all from my side. Meanwhile, I'll tell you people something which is really special about Spain. Another thing is, do you know that when we talk about Spaniards, they have 2 surnames? Yeah, they're the people who have 2 surnames because they write the surname of their mother as well as they write the surname of their father. That's why whenever you talk about a person from Spain, you will find that after their first name, they will be having 2 surnames, right? Another special thing about Spain, obviously there's much more which I'm going to discuss when I'm going to be talking about the rest of the lecture on the other side when you click on the link. And if you're really interested in knowing this topic of heights and distances really well, so obviously in the description, except this link where you should click to get the rest of the lecture, there will be another link to which you can click, and you will get the complete series of heights and distances where you can really enrich yourself in this topic. And then any topic, if there is like angle of elevation, angle of depression, on which questions are asked, then you'll be able to answer them with utter ease. So bye children, have a nice time. Bye.